did the woman in the last video where she put a glucose and starch, I think, did she use those solutions?
Which video we are talking about? The lady.
Yes, the lady who put some starch and glucose or something like that.
Okay, yes, I'm sure that she was doing the test on that one. So let me see the video. Maybe we'll be able to recall. So let me go to the next slide where we have the link. Uh, I didn't put the link on this, so just hold on. Let me go to the canvas. And let us see the video on this. This is the one I was looking for. So hold on. Yes, Khalid, you might be right about the lady who was doing the experiment. So let me show you another video based on the enzymes introduction. And the next video, during the next lesson, I'll show you the experiment because the experiment link is not updated. I'll update it in the next lesson and we'll watch it. So let me open up this one. Let me resume the share. Are you guys able to see the, where is it? This one. Yes, the enzyme video.
Hello and welcome to our channel. Today we are going to be discussing the topic of enzymes.
Is there voice on this video? Can you guys hear it? Okay, good. So let me
Enzymes are
maximize it.
biological catalysts which speed up the reaction rate without actually getting involved with the reaction itself. Examples of enzymes: salivary amylase, pepsin, renin, lipase, catalase, isomerase, phosphorylase, maltase, lactase, sucrase. Types of enzymes. Carbohydrase digests the carbohydrates, e.g. salivary amylase. Protease digests the proteins, e.g. pepsin. Lipase digests the fats, e.g. enzymes from the pancreas. How an enzyme works. An enzyme has an active site similar to the shape of the substrata. When the enzyme comes into contact with the substrata, it fits like a jigsaw and exerts pressure onto the substrata at a specific point so that it breaks up into a simpler substance. The properties of enzymes. All enzymes are proteins. All enzymes work best at a specific temperature, known as the optimum temperature. Enzymes get denatured, lose shape of their active site, if its optimum temperature is exceeded. Enzymes work the fastest at a specific pH level and, like temperature, get denatured when the pH exceeds the optimum.
All right, this point is very important that she's telling you that the enzymes, they have to have a temperature where they are happy to work. We call that an optimum temperature. If you're discussing the human body, we have to have the temperature max that we can go is about 40 degrees Celsius. If we go above that point, we start not only feeling uneasy, also our enzymes will be unable to do their job and they will become denatured. The problem is if they become denatured, the word over here that we highlighted, if they start becoming denatured, then it means they will not be able to work and they are permanently damaged. So we have to create new enzymes. So the body is actually producing new enzymes to replace the denatured ones. So if the temperature of the body goes above 40, we are sick. Are all of the enzymes in the human body, in every cell, will not be able to function like they used to, and we start feeling weak, tired, and also we lost the taste. Second, the thing she mentioned is about the pH. The pH is how much acidic or basic it is. If we take an example of a mayonnaise which is in our mouth, it has to be something around basic. It has to be, sorry, something around 6.5 to 7, something neutral, a little bit acidic. But if we change that acidic level to a high level, then this amylase will not be able to work. So any enzyme which is inside the body, inside the cell, and they are not being provided with the right temperature or the right pH, they can get denatured, and once they are denatured, they are permanently damaged. They cannot repair themselves. They cannot be fixed. So they will be wasted out of the body, and we'll have to create new enzymes, which cost a lot of energy. So you might have seen that when we are sick, when we recover, we take a lot of time to recover. It's because the enzyme production is not an easy job. And that's why we are recycling them to keep ourselves healthy. So once we have lost them, we have denatured them, we have to develop new. So it will take time, and every cell produces enzyme in a few days. So you're fully recovered and you start working like a normal person. So let me clear all this and let's go back to the video.
Enzymes are specific in nature. They can only break down a specific substrata. Factors affecting enzymes. Temperature. As the temperature of a reaction mixture increases, the kinetic energy inside the reacting particles increases as well. This leads to a high collision frequency to build up. This causes the substrata and the enzyme to collide more frequently and thus increases the rate of reaction. However,
Okay, this one we have an activity for this whole subject. We have an activity on the canvas, and it is, I believe, this one. Let's try to open it up, and we need to enable. Yes, this is where it shows you the movement. Look, if it goes and moves exactly like this, they will be able to join with each other. They will be able to do its function. But if we start heating it up, they will start moving faster. So faster means high kinetic energy. The word kinetic energy shows the movement speed of these molecules. There was another link which showed this one as well. This is a problem. We have to open this link in another browser, which would be Internet Explorer. What is this? Okay, let's keep it. Okay, let me make a new file share. I hope you can see this. Over here, we have the enzymes. We can increase the number of enzymes. Let's say I'm putting 20 enzymes. And we have about 50, let's say 35 substrate, the food molecule. There are no inhibitors right now. The temperature is 25. The container size is 400. And let's see. This is how it's going to look like. The green ones are the enzyme. The blue ones are the food molecules, right? Red ones are going to be the products. And inhibitors, let me show you some inhibitors. Let's put 10 inhibitors. So they are going to move. If I'm going to decrease the temperature, let me start from 5 degrees Celsius. You're going to see that they're going to move very slow. And the red ones are the products. Once A blue molecule comes into the enzyme, it is going to be changed into a red molecule, which is a product. So you can see now they are finished. And one last to go. This one is the last molecule. Yes, now we have done it all. So let me increase the temperature. What was going to happen when the temperature increases? They're going to move faster. Let me stop this. This is the new setup. Okay. So they're moving faster at 40 degrees. How much time is it going to take? And we are almost done. 4 molecules left. 3, 2, and 1. Last one. Yes, we have chat. What is this? Mufti. And moving things. Okay, let me stop it. Now they're not moving. Look at this again. The green molecules, the large size, are your enzymes, right? And the blue ones are the food molecules. The red is when the enzyme changes it into a product, and the yellow ones are the inhibitors. I'm going to remove the inhibitors because we didn't study inhibitors. So look at this. If I move, let them move like this, look how fast they can move. Inhibitors are the blockers. They would stop them to do their job. And without inhibitors, look, they have finished already. Everything is done within 10 seconds. But if I increase the temperature to 50 degrees, and then if I let them start, it is still working, but slower. If I increase the temperature to 60, what's going to happen? Nothing is working. No product is produced because the temperature is too high. Khalid is raising a hand. Yes, Khalid.
Mister, so what do you mean? So, if now in Corona time, if somebody put the machine in your head and your temperature is 60, does that happen to your enzymes?
Yes, the body will not be able to function. At 60 degrees, everything is going to stop working. If even at, I think, 50, it shouldn't be doing any kind of work. But it is working. Anyways, the enzymes, but on 50 degrees Celsius, it is functioning, but at 55, it's going to be absolutely stopped. Yes, at 55, look, it doesn't work at all. So all the functions of your body will stop working. All functions in your body are happening because of the enzymes. Everything's going to stop working. Let's check with the, let me stop. Let's check if we have 45, but we have pH, which is 10. What's going to happen? If you disturb the pH, again, your enzymes will not be able to work. Okay, Abdul Samad is raising a hand. Yes, Abdul Samad.
Mister, just to be sure, the usual temperature of the body is 37 and 36, right?
Yes.
But how is it inside? It's working perfectly at 40. 40 is a bit
Because
too.
it's an animation, and there is an error. There's a bug. I would agree with you that it shouldn't be working above 40. We'll see there's a graph which will show us that if we go above 40, the enzymes will stop working.
Mister, in
Yes.
real life, what's the limit to the temperature? 42 or 43?
The limit 40,
Yes.
after 40, it starts declining. It stops working after 40. 40 is the max that we can go. We have question from Yasin. Yes, Yasin.
Yes, Mister. Mister, I have question. When the body temperature is very high, more than 45, what will gonna be? What gonna be?
The enzymes will stop working. We might have taken the soda. How many of you have taken soda?
Which soda? Which soda?
Not soda, soda,
Oh yes.
Sauna, where you're sitting in a box, in a wooden box, and the temperature is about 70 degrees and 80 degrees. You stay there for 10 minutes to 15 minutes, you sweat a lot, and you come out. It's like a steam bath.
Okay.
That time, your enzymes actually stop working, they are becoming denatured, and you are replacing your old enzymes with the new ones. So that's why
Okay,
you
Mister.
feel.
But if it's very cold,
If you
the
go to
temperature.
very cold, yes, even at very cold, it won't work
Why?
because they like it that way. The chemical reactions, if we decrease the temperature up to 20, less than 15, it shouldn't be working good. It will be working very slow. Look at the result. I'm gonna decrease the pH, and look, they are working very slow now. So the
Okay.
movement also becomes slow with the lower temperature.
Thank you, Mister.
You're welcome. So, boys, we are done with the session for today. And if you have any questions, please leave them on my email. I'll try to answer them back to you. And until we meet again, take care of yourselves. Stay safe, stay blessed. Assalamu alaikum wa rahmatullahi wa barakatuh.